We shall now discuss some problems on trigonometric equations. Problem number 1. The principal value of theta plus pi by 4 where sin theta plus cos theta is equal to 1 is first option 0, second option pi by 3, third option pi by 4 and fourth option pi by 2. Now, sin theta plus cos theta is equal to 1. Generally, when we are solving a trigonometric equation, we have to bring the equation into one trigonometric ratio. Now, there are both sin theta and cos theta. Can we bring it into 1? I'll multiply both sides by 1 by root 2. So, sin theta cos theta by root 2 is equal to 1 by root 2. Now, this 1 by root 2 we can treat it as cos pi by 4, and this 1 by root 2 which you have here we can treat it as sin pi by 4. Therefore, it is in the form of sin theta cos pi by 4 plus cos theta sin pi by 4. That is nothing but sin of theta plus pi by 4 is equal to therefore 1 by root 2. But what is this 1 by root 2? That is, this implies sin of theta plus pi by 4, we can write it in the form of sin pi by 4. Sin pi by 4. Now, theta plus pi by 4 is therefore equal to theta plus pi by 4 is equal to n pi plus minus 1 power n into pi by 4. Now, so this theta plus pi by 4 is what you wanted here. We wanted the principal value of theta plus pi by 4. What do you mean by principal value? That value which lies between minus pi by 2 to pi by 2. So here theta plus pi by 4 has to be therefore pi by 4. So that is pi by 4. So the principal value of theta plus pi by 4 is pi by 4, because that is the only value which will lie between minus pi by 2 to pi by 2. So theta plus principal value now principal value of sin x equal to some k, that x has to be belonging to minus pi by 2 to pi by 2, closed minus pi by 2 to pi by 2. So when I am solving for sin x equal to k equation, what is that value? It has a general solution. What is the general solution? If you pick, there will be a unique value of x for which sin x is equal to k in the interval minus k to minus pi by 2 to pi by 2. Now the general solution, suppose alpha is the principal value. Alpha is the principal value of this equation. That means sin alpha is k and alpha belongs to minus pi by 2 to pi by 2. Then the general solution is of this equation sin x equal to k is x equal to n pi plus minus 1 power n into alpha. Now this is a note that we must keep in mind. Here, therefore, I wrote the general solution theta plus pi by 4. I wrote it as n pi plus minus 1 power n into pi by 4. But I want this to be belonging to minus pi by 2 to pi by 2. So if I take n to be 0, I will get that value. So n can be any integer here. So take n to be 0 so that you get the value which lies between minus pi by 2 to pi by 2. So that is the principal value. Therefore, the answer for this question is option 3 is the right answer. So let's move on to the next question. If tan theta plus secant theta is equal to root 3, then the principal value of theta plus pi by 6 is. Now let's have a look at this options. First option pi by 4, second option pi by 3, third option 2 pi by 3, fourth option 3 pi by 4. Now secant theta plus tan theta is equal to root 3. From here, secant theta minus tan theta, which is the reciprocal of secant theta plus tan theta, has to be 1 by root 3. Let's add up these two equations. What do you get? 2 secant theta is equal to root 3 plus 1 by root 3. Adding. So that makes it 3 plus 1, that is 4 by root 3. That is 2 secant theta, which in turn implies secant theta to be equal to 2 by root 3. Which in turn implies that cos theta is equal to root 3 by 2. Cos theta is equal to root 3 by 2. But what is that? What is that? Cos pi by 6. Okay. Now, so theta here is equal to 2n pi plus or minus pi by 6. Okay. So what is it? So your theta plus pi by 6 will be 2n pi plus pi by 3 or 2n pi. Okay, because you can have a minus or plus. Now here let me just recall that whenever you write cos theta equal to some cos alpha, cos theta is equal to k and k is equal to cos alpha for some alpha belonging to 0 comma pi. This alpha is called the principal value. So the principal value of cos theta equal to k, that solution, that equation will have to lie between, the principal solution should lie between 0 to pi. Okay. Now what is that value? We are interested in the principal value. So for what value of n can you get a number between 0 to pi? So n equal to 0 if I give, I get a value to be pi by 3. So what's the answer? Take n to be 0. Take n as 0 in this case, then we get theta plus pi by 6 to be equal to pi by 3. Okay. So if n is 0, we also get 0, but that's not given in the options here. So let's take this value, that is between pi by, it is pi by 3 here. Yes. So the principal value is pi by 3. Now the principal value of theta plus pi by 6 is pi by 3. So answer is option 2 is the right answer. Let's move to the next question. Question number 3. The general solution of the equation tan 3x minus tan 2x by 1 plus tan 3x tan 2x is equal to 1 is, first option, n pi plus pi by 4 for all n integers. Second option, n pi plus or minus pi by 4 for all n integers. Third option, null set. Fourth option, n pi plus pi by 6 for all n integers. Now let's look at this equation, tan 3x minus tan 2x by 1 plus tan 3x tan 2x is equal to 1. Now clearly this is in the form of tan A minus tan B, tan A minus tan B by 1 plus tan A tan B. What is that formula? It's tan of A minus B. So this I can write it in the form of tan of 3x minus 2x is equal to 1. But what is that 1? I can say it is tan pi by 4. Pi by 4 being the principal value of that. Now tan x is therefore is equal to 1. This gives us, if you solve, x to be equal to n pi plus pi by 4. But okay, we cannot jump to the conclusion that this is the solution. Here we went for a transformation, we went for a formula. This was the original equation. We went for a formula, tan of a minus b formula, and made that equation look like tan x equal to 1. And hence we got the solution. But it was not originally tan x equal to 1 equation. So this solution that we got to substitute in the given equation and verify whether it is satisfying the domain requirements of that equation or not, or is it satisfying the original equation or not. What is the domain requirement? That is, every term in this should be valid when I put x equal to n pi plus pi by 4. We observe that 2x will imply this 2x will become 2n pi plus pi by 2. So if x is equal to n pi plus pi by 4, 2x will be 2n pi plus pi by 2, and tan 2x becomes undefined. So although this x equal to n pi plus pi by 4 satisfies the last equation, that the derived equation, this cannot be taken as a solution for the given equation because it is not fulfilling the domain requirement. So tan 2x is one part of this equation is becoming undefined when I try to substitute the value of x there. So hence we cannot say that this is the solution, but the only possible way, the only possible solution would have been this, okay, and that was also not fulfilling the original equation. So hence no solution. Hence the equation has no solution. Or we write it in this form, empty set. The solution set is empty set, is equal to empty set. Therefore the option 3 is the right option. Option 3 is right answer. Let's move to the next question, question number 4. Tan of pi by 4 plus a by 2 plus tan of pi by 4 minus a by 2 is equal to 4 by root 3. Then the general solution of a is equal to, first option, 2n pi plus r minus pi by 6 for all n integers. Second option, n pi plus pi by 4 for all n integers. Third option, 2n pi plus r minus pi by 4 for all n integers. Fourth option, n pi, n any integer. So let's look at this. Tan of pi by 4 plus a by 2. What is tan of a plus b formula? Tan of tan a plus tan b by 1 minus tan a tan b. So that makes it 1 plus tan a by 2 by 1 minus tan a by 2. What about tan of pi by 4 minus a by 2? That's going to be, we'll use the formula tan of a minus b. So tan pi by 4, that is 1 minus tan a by 2 divided by 1 plus tan pi by 4 tan a by 2. So the 1 plus tan a by 2. Now we got to add these two. Let's add these two and equate it to 4 by root 3. So what do we have now? Tan of pi by 4 plus a by 2 plus tan of pi by 4 minus a by 2 is given to be 4 by root 3. This is what is given. Okay, this is given. But what did you find this to be? So that makes it 1 plus tan a by 2 by 1 minus tan a by 2 plus 1 minus tan a by 2 by 1 plus tan a by 2 is equal to 4 by root 3. Okay, so that gives me this, because 1 plus tan a by 2 whole square plus 1 minus tan a by 2 the whole square, what is that equal to? 2 into 1 plus tan square a by 2 and divided by, in the LCM will be 1 minus tan square a by 2. That is equal to 4 by root 3. So this 2 will cancel and we have 2 by root 3 there. But what is this? This is in the form of cos 2a, 1 by cos 2a. We know that cos 2a has a form, cos a has a formula, cos a is having a formula like this: 1 minus tan square a by 2 by 1 plus tan square by 2. Okay. Cos 2a would have been 1 minus tan square a by 1 plus tan square a. It is because it is having a submultiple. Let's go for this. Cos a is equal to 1 minus tan square a by 2 by 1 plus tan square a by 2. So you have the reverse. So this becomes, therefore, 1 by cos a is what you have, and that is equal to 2 by root 3. So this equation that you have here is actually 2 by root 3. So cos a is equal to root 3 by 2. So what is root 3 by 2? Cos of what angle is it root 3 by 2? So cos of pi by 6. Why did I choose pi by 6? That's a principal value here. Now we already have understood that whenever cos a is equal to cos alpha, the general solution is given by 2n pi plus or minus alpha. Instead of alpha, I have pi by 6. So n can be any integer here. This is the most general solution of A, and that is clearly appearing in the option 1 is the right answer. Let's move on to the next question. Question number 5. Sin A is equal to sin B and cos A is equal to cos B. Then A is equal to what? In terms of B, there are options. First option, n pi plus b, n any integer. Second option, 2n pi plus b, n any integer. Third option, 2n pi minus b for all n integers. Fourth option, 2n pi plus r minus b for all n integers. Now we are given sin A is equal to sin B. Now from here, sin A minus sin B is 0. But what is sin A minus sin B? 2 cos A plus B by 2 into sin of A minus B by 2. 0. Let's keep it aside. Now we are also having cos A minus cos B is 0. This is given. So what implies? It implies this. So what else is given? Cos A minus cos B is 0. But what is cos A minus cos B formula? 2 sin A plus B by 2 into sin of second angle minus first angle B minus A by 2. Now what is that factor which makes both these expressions 0 simultaneously? So if these two are to be 0 simultaneously, what we should equate the factor which is common to both these equations to 0. So therefore what is that common factor there? Sin of A minus B by 2. Actually I could write this as minus of sin of A minus B by 2. So clearly if I take sin of A minus B by 2 0, both these expressions become simultaneously 0. Therefore we can say that sin of A minus B by 2 has to be 0. But when is sin theta 0? When theta is multiple of pi. So A minus B by 2 must be a multiple of pi, n pi, n any integer. So which gives me A to be, A minus B to be 2n pi. So this implies A must be equal to 2n pi plus B, n any integer. So what is the right option? The option 2 is the right answer. So we'll move on to the next question here. Cos cube alpha plus cos cube of 120 plus alpha plus cos cube of 120 minus alpha is equal to 3 root 3 by 4. Then the general solution of alpha is, first option, null set. Second option, 2n pi plus or minus pi by 3 for all n integers. Third option, 2n plus 1 into pi by 2, n any integer. Fourth option, n pi, n any integer. Now, what's the equation given? Cos cube alpha plus cos cube of 120 minus 120 plus alpha plus cos cube of 120 minus alpha is equal to 3 root 3 by 4. Now there is a formula for this. This has to be memorized. This left hand side is equal to 3/4 of cos 3 alpha. Even if you don't remember the formula, you can just go go for cos of a plus b and expand it and club it. What is cos 3 alpha? 4 cos cube alpha minus 3 cos alpha. Okay. So recall this formula. This turns out to be cos cube alpha plus cos cube of 120 plus alpha plus cos cube of 120 minus alpha. This has to be memorized. Remember this. Remember this formula. So that is equal to 3 root 3 by 4. Now this 3 by 4 will cancel. So what are we getting here? Cos 3 alpha is equal to root 3. Root 3 is a number greater than 1. So can cos of any number be greater than 1? No. So that means what? This has no solution. This equation has no solution. No value of alpha. Hence, empty set is the solution set. Solution set is empty set. So, which is appearing in the first option. Option 1 is the right answer. So, option 1 is the right answer. So, the formula that you have to remember is cos cube alpha plus cos cube of 120 plus alpha plus cos cube of 120 minus alpha is 3/4 of cos 3 alpha. This is equal to 3 by 4 cos 3 alpha. This has to be memorized. Let's move on to the next question. Question number 7. If tan x plus 2 tan 2x plus 4 tan 4x plus 8 cot 8x is equal to root 3, then the general solution of x is equal to, first option n pi plus pi by 3 n any integer, second option n pi plus pi by 6 n any integer, third option n pi plus pi by 4 n any integer, fourth option n pi n any integer. The equation given to us is tan x plus 2 tan 2x plus 4 tan 4x plus 8 cot 8x is equal to root 3. We have to find a solution for general solution for this. Now there is one formula that you need to know. Tan x plus 2 power 1 into tan 2 power 1x plus 2 square into tan of 2 square x plus 2 cube into tan of 2 cube x, so on and so forth. Let's write up to n terms. You can go up to any n. 2 power n minus 1 into tan of 2 power n minus 1 into x. But the next term you write it with cot. Next term in the series we write with a cot. So what is that? 2 power n into cot of 2 power n x. That comes out to be cot x. So this is a formula that we need to memorize. Remember this formula. Remember this formula. It comes in the telescoping form. So tan x plus 2 tan 2x plus 2 square tan of 2 square x plus 2 cube. So there is a pattern here. You write up to n terms, that is 2 power n minus 1 into tan of 2 power n minus 1 x. But the last term you write with, it should come in the same series, but instead of tan you will write cot. Then all that summation will turn out to be equal to cot x. So here, what is this going to be? Is it in that pattern? Of course, here we have 4 terms. Now we are going up to 2 power of 3 minus 1. So n is 3 here. So we have, anyway, this entire thing comes out to be cot x. So LHS will turn out to be cot x. Cot x is equal to root 3 is what you are asked to solve. That's all. So now this will mean tan x is equal to 1 by root 3. What is it? 1 by, what is the principal value of tan x being equal to 1 by root 3? Tan of pi by 6 is 1 by root 3. We know that. So here, this, what is general solution? X is equal to n pi plus pi by 6. So let's one more thing that we should know is if tan x is equal to k, and that, right, we are trying to solve this. How do we write the general solution for this? We pick up k some real number, because the range of tan function is all real numbers. It's solvable for any k real number. Now there exists some unique alpha belonging to minus pi by 2 to pi by 2, which shall be called such that tan alpha is equal to k. Such an alpha is called the principal value. It's called the principal value. Now once you know the principal value, how to write the general value of this equation, general solution. So the general solution is given by n pi plus alpha. So general solution of tan x equal to k, where alpha is one of the solutions which lies between minus pi by 2 to pi by 2 open interval, okay, is given by n pi plus alpha. That's what we have used here. Pi by 6, tan pi by 6 is equal to 1 by root 3. That pi by 6 is the general principal value. So we wrote the general solution. This is the general solution. General solution is therefore n pi plus pi by 6, and can be any integer. So that is clearly appearing in the option 2. So option 2 is the right answer. Let's move to the next question. Question number 8. If tan a plus tan 2a plus root 3 tan a tan 2a is equal to root 3, then the general solution of a by 2 is equal to, first option, n pi by 3 plus pi by 9 for all n integers. Second option, n pi plus pi by 9 for all n integers. Third option, n pi by 6 plus pi by 18 for all n integers. Fourth option, n pi by 3 plus pi by 4 n any integer. Now let's have a look at this equation here. Tan a plus tan 2a plus root 3 tan a tan 2a tan 2a is equal to root 3. We will transpose this term the other side. So what do we have here? Tan a plus tan 2a is equal to root 3 into 1 minus tan a tan 2a. Now it is appearing in the form of tan a plus tan b, and you have a 1 minus tan a tan b. Bring it down. So we can write this as tan 2a plus tan a by 1 minus tan 2a tan a. That is equal to root 3. Now this is clearly in the form of tan of a plus b. That is, it is in the form of tan of 2a plus a, which is equal to root 3. So tan 3a is equal to root 3. So what is this? What is the general value? We know 3a is equal to, this is tan pi by 3. So let's write the general value. 3a will be equal to n pi plus pi by 3. So this implies a will be equal to n pi by 3 plus pi by 9. But we are interested in a by 2 value. So a by 2 value will be n pi by 3 by 2. So that is plus pi by 2 into 9. That is n pi by 6 plus pi by 18. N any integer. So clearly a by 2 is the general solution of a by 2 is n pi by 6 plus pi by 18. Option 3 is the right answer. Option 3 is the right answer. Question 9. If sin x plus cos x is equal to root 2 cos alpha, then x is equal to what? 2n pi minus pi by 4 plus r minus alpha, n pi minus pi by 4 plus alpha, 2n pi plus pi by 4 plus r minus alpha. Fourth option, n pi minus pi by 4 plus r minus alpha. We are given sin x plus cos x to be equal to root 2 cos alpha. Now I will write this, bring this root 2 down here, 1 by root 2 into sin x plus 1 by root 2 into cos x is equal to cos alpha. Since you have cos alpha on the right hand side, let's try to bring this expression as cos of something. Now this we can look at it as sin pi by 4, and this we can take it as cos pi by 4. Now what is cos A cos B plus sin A sin B? That is equal to cos of A minus B. So this becomes cos of x minus pi by 4, and that is equal to cos alpha. So what is the general solution here? X minus pi by 4 can be written as 2n pi plus r minus alpha n any integer. So x will be 2n pi plus r minus alpha plus pi by 4 n any integer. So and that's clearly appearing in the option 3. Option 3 is the right answer. So option 3 is the right answer. Now let's move to the next question. Sin x plus cos x is equal to 1 plus sin x into cos x, then x value is equal to, first option n pi plus pi by 3 n any integer, second option n pi plus minus 1 power n into pi by 6 n in integer, third option n pi plus minus 1 power n into pi by 2 n any integer, fourth option n pi. Now the sin x plus cos x is equal to 1 plus sin x into cos x. This is what is given to us. Now this equation is involving more than one trigonometric ratio. I want to bring it into an equation involving only one trigonometric ratio. So how do we do that? What we do is we'll go for a substitution. Sin x plus cos x is equal to t. Now squaring what? Squaring. We will get sin square x plus cos square x is 1. 1 plus 2 sin x cos x is equal to t square. So sin x cos x can now be written as t square minus 1 by 2. So here we will rewrite the equation as an algebraic equation in t, solve for t, and then get back to the value of x. Okay, let's see how we do that. So sin x cos x is t square minus 1 by 2. The equation now can be brought in terms of t, an algebraic equation. T is equal to 1 plus t square minus 1 by 2, and that we can write it as t square plus 1 by 2. Okay, that is t. So therefore, what do we have? T square minus 2t plus 1 is equal to 0. So t minus 1 whole square is 0. So t has to be 1. This implies t is 1. So we have here t to be 1. Okay. So t is 1, therefore sin x plus cos x has to be 1. Let's get back to seeing what is t. T was sin x plus cos x. So that's 1. Now how do I solve this? We'll multiply by root 2 and divide by root 2 on both sides. So this becomes here 1 by root 2 sin x plus 1 by root 2 cos x is equal to 1 by root 2. So this is again sine. I can either look at it as cos of x minus pi by 4 or sine of x plus pi by 4 is equal to, this is sine pi by 4. This gives us the general solution. X plus pi by 4 is equal to n pi plus minus 1 power n into pi by 4. N pi plus minus 1 power n into pi by 4. So clearly, what do we get from here? Now there are two possibilities here. You can have n, if n is even, you will have 2n pi, n is 2m, let us say. So this will become 2m pi plus pi by 4. X plus pi by 4 will become 2m pi plus pi by 4. That gives me 2m pi. But 2m pi is not an option that is given to us. Suppose n is of the form 2m plus 1 into pi. N is of the form 2m plus 1. So then this becomes 2m plus 1 into pi minus pi by 4. So we can bring it that side, and that gives me x to be equal to 2m plus 1 into pi minus pi by 2. Okay, so now I can treat this as some n, it is an integer. So n pi minus pi by 2. So one of the possible options here that is coming out to be that is giving this one is the third option. Third option gives us, so option 3 is the right answer. Let's move to the next question, question number 11. Given that tan A and tan B are the roots of the equation x square minus bx plus c equal to 0, the value of sine square of a plus b is, first option b by b plus c whole square, second option b square by b square plus c square, third option b square by c square plus 1 minus b square, fourth option b square by b square plus 1 minus c whole square. X square minus bx plus c equal to 0 has roots are tan A and tan B. So tan A plus B, what is tan of A plus B? Tan A plus tan B divided by 1 minus tan A tan B. This tan A plus tan B will mean the sum of the roots. This is x square minus bx plus c. So sum of the roots is what here? B. So we will get b here, numerator. What about the product of the roots? C. C by 1. That is c. So 1 minus c. So tan of A plus B is coming out to be b by 1 minus c. So let us think that, construct a rectangle. We have b by 1 minus c. Let us think that this is A plus B. So this will be obviously b square plus 1 minus c the whole square under root hypotenuse. So that clearly gives us sine of A plus B to be equal to opposite by hypotenuse. So b by under root over b square plus 1 minus c the whole square. So clearly sine square of A plus B will give me b square by, the square root will go and we'll have b square by b square plus 1 minus c the whole square. So then that is clearly appearing in the option 4. Option 4 is the right answer. That's the right answer. Let's move to the next question, question number 12. The general solution of sin x raised to the power 100 minus cos x raised to the power 100 is equal to 1 is, first option 2n pi plus pi by 3 n any integer, second option n pi plus pi by 4 n any integer, third option n pi plus pi by 2 n any integer, fourth option 2n pi minus pi by 3 n any integer. Now what is the equation? Sin x raised to the power 100 minus cos x raised to the power 100 is equal to 1. We will rewrite this equation as sin x raised to the power 100 is equal to 1 plus cos x raised to the power 100. 1 plus cos x raised to the power 100. We know that this 1 plus cos x raised to the power 100 is always greater than or equal to 1 because cos x to the power 100 is always greater than or equal to 0. So that is sin x power 100 has been equated to some quantity which is always greater than or equal to 1. But can sin x power 100 be greater than 1? It can't be. So this will happen only when it is equal to 1, right? And what is it you should have? Cos x power 100 should be 0 then. So this will imply sin x power 100 has to be 1 and cos x power 100 has to be 0. The reason is sin x power 100 is less than or equal to 1, but you are saying that you are trying to equate it to a quantity which is greater than or equal to 1. When is that going to happen? When both sides are equal to 1. So now that is sin x power 100 should be equal to 1 and cos x power 100 plus 1 should be equal to 1. That means cos x power 100 should be 0. So sin square x has to be 1, okay, and cos, of course this implies cos x has to be 0. So that is, when is that going to happen? This happens whenever x is of the form n pi plus pi by 2. Okay, x is of the form n pi plus pi by 2, n any integer. So that is clearly appearing in the option 3 is the right answer. Question number 13. The values of theta satisfying sin phi theta is equal to sin 3 theta minus sin theta, where theta belongs to 0 comma pi by 2 open interval are pi by 6 comma pi by 3, second option pi by 6 comma pi by 4, third option pi by 4 comma pi by 3, fourth option pi by 4 comma pi by 2. So let's look at the equation. Sin phi theta is equal to sin 3 theta minus sin theta. We have to solve for this equation and pick up the solutions which lie only in the open interval 0 comma pi by 2. So let's see that how we do it. Sin phi theta, I transpose this minus sin theta at this side. Sin theta is equal to sin 3 theta. Now it is in the form of sin A plus sin B. What is the formula for sin A plus sin B? 2 sin A plus B by 2, that is 5 theta plus theta by 2 into cos of 5 theta minus theta by 2 is equal to sin 3 theta. So that gives us 2 sin theta 3 theta into cos 2 theta minus sin 3 theta is equal to 0. I am again transposing the sin 3 theta this side. We can take out sin 3 theta common and we can write this as 2 cos 2 theta minus 1 is equal to 0. So that gives me sin 3 theta is equal to 0 or cos 2 theta is equal to 1 by 2. Cos 2 theta is equal to 1 by 2. But what is that sin theta? 3 theta has to be n pi, general value. When is cos 2 theta equal to half? 2 theta is equal to, this is cos pi by 3. So 2 theta should be equal to 2n pi plus or minus pi by 3. That's a general value. So theta will have to be equal to n pi by 2 plus or minus pi by 6. So here theta can be, I will write it as some m any integer. Here n any integer, m pi by 3. Okay, now we are interested in the values of theta which only lie between 0 to pi by 3, pi by 2. So let's keep giving values to m and n and pick up the values which will fall in the interval 0 to pi by 2. Okay, so let's give m equal to, if I give m equal to 1, right, m is 1. So that gives me theta equal to pi by 3. And here if I give n equal to 0 and take a plus sign here, I am going to get pi by 6. So take n equal to 0 and take plus sign, and that gives us theta to be pi by 6. So no other value will lie between 0 to pi by 2. So the two values, theta can be either pi by 3 or pi by 6. So these are the two values which lie between 0 to pi by 2. Theta belonging to open interval 0 to pi by 2. That's what we were interested in. So clearly the option 1 is the right answer. Option 1 is the right answer. Let's move to the next question, question number 14. The equation sin x power 6 plus cos x power 6 equal to lambda has a solution if, first option, lambda belongs to closed interval half comma 1. Second option, lambda belongs to closed interval 1 by 4 comma 1. Third option, lambda belongs to minus 1 comma 1. Lambda belongs to minus 2 comma 2. Sin x power 6 plus cos x power 6 is equal to lambda. So we wanted to know for what values of lambda is this equation solvable for x. Meaning I need to find out the range of this sin x power 6 plus cos x power 6 function. So let us consider this function f of x is equal to sin x power 6 plus cos x power 6. Let's find the range of it. Now this is equal to sin square x plus cos square x whole cube minus 3 sin square x cos square x into sine square x plus cos square x. How did we write this? A cube plus b cube, we are using this formula, a cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b. We are using this formula. So this can be viewed as sine square x whole cube, sine cos square x whole cube. So a cube plus b cube, that is it. And now this is clearly 1 minus 3 sine square x cos square x. Okay. So, and this of course is 3 by 4 multiply and divide by 4. So 4 sine square x cos square x. And what is this? 2 sine x cos x is equal to sine 2x. So I can write this as 1 minus 3 by 4 of sine square 2x. Sine square 2x. But what do you know about sine square 2x? We know the range of sine square 2x to be lying between 0 to 1. Its range is 0 to 1. So 3/4 of sine square 2x will lie between 0 to 3 by 4. So 1 minus 3/4 of sine square 2x will have to lie between 1 minus 3 by 4 to 1 minus 0. 1 minus 0. So that is, this is your f of x. F of x should lie between 1 by 4 to 1. The range of f of x is therefore 1 by 4 to 1. So only when we have lambda to be equated to the some value between 1 by 4 to 1, we will be able to solve for x. So this is what we have to do here, and therefore the option is option 2 is the right answer. Option 2 is the right answer. Let's move to the next question. The number of solutions of the equation 2 power cos x is equal to mod sin x in the interval minus 2 pi to 2 pi closed is first option 1, second option 4, third option 3 and fourth option 2. Here 2 power cos x is to be equated to mod sin x. When you have two different types of functions and we are trying to seek solutions, one method is the graphical method, the other method is we find the range of both the functions. What is the range of for x belonging to minus 2 pi to 2 pi? You know that cos x lies between minus 1 to 1. So 2 power cos x will be lying between 1 by 2 to 2. Okay. Right. So it is definitely, it's going to be between 1 by 2 to 2. What about mod sin x? What about mod sin x? The range of mod sin x is between 0 to 1. Okay. The range of mod sin x is between 0 to 1. So we will have to equate, when is this 2 power cos x is equal to mod sin x? We will have to see, and for what values of x can that happen. Now what we will do is, we found the ranges of 2 power cos x and 2 mod sin x. We will have to see for how many values of x these two graphs are going to be intersecting. Now let us look at here. This 2 power cos x is an even function, because cos x is an even function, 2 power cos x is an even function. So is this mod sin x. Let's first plot the graph of mod sin x. It looks like this. 0 to pi, it's like this. Pi to 2 pi, it's like this. Now, and the same thing will repeat, minus pi to 0 and also minus 2 pi to minus pi. This is y equal to mod sin x graph. Let us plot 2 power cos x graph. When x is 0, this is the line y, highest value point is, this is the line y equal to 1. When x is 0, cos x will become 1. So, we will start with 2 power 1, that makes it 2, 0 comma 2 is a point on the graph. When x is pi by 2, cos x becomes, now cos x decreases, so will 2 power cos x will also decrease. When x is pi by 2, it comes close to 1 there. I mean, it becomes 2 power of 0 and that becomes 1. Again, when x is equal to pi, and when x is equal to pi here, we have, it will go to 1 by 2. It will go to 1 by 2. So, it comes like this. Goes to 1 by 2. And then here, alright, again it will move up from here and then again touch at 3 pi by 2. At 3 pi by 2, again what do we have? 2 power 0 and that becomes 1 there. It moves up. We observe that there are two solutions in between 0 to 2 pi. So, same thing will repeat here also. We will have two more between minus 2 pi to 0. So, there are in all 4 solutions which satisfy this 2 power cos x is equal to mod sin x, and hence the answer is 2. Answer is second option. Option 2 is the right answer. Let us move to the next question, question number 16. The equation 2 cos square x by 2 into sin square x equal to x square plus 1 by x square, where x lies between 0 to pi by 2 has, first option, one real solution, second option, no solution, third option, more than one real solution, fourth option, two solutions. Let us have a look at this. Again, 2 cos square x by 2 into sin square x is equated to x square plus 1 by x square. The left hand side is a trigonometric expression and the right hand side is an algebraic expression. So, when we are given such problems, what we need to do is we first find the range of each of the left hand member and right hand member separately. So, what do? We know that this cos square x by 2 into sin square x is at the maximum 2, because cos square x by 2, of course this cannot be 2 maybe, but here the maximum value cannot exceed 2, we can say that, less than or equal to 2. What about this? This is at least 2. Okay, this is going to be at least 2. So, when can equality hold good? Equality can be true when both are equal to 2. Both LHS is equal to RHS is equal to 2. But when is RHS equal to 2? That is, x has to be plus or minus 1. RHS is 2, but RHS is 2 if and only if x is equal to plus or minus 1. But we are interested in the positive value. So, x has to be 1. But if I put x equal to 1, what do I have on LHS? LHS becomes 2 cos square 1 by 2. So, for x equal to 1, what is our LHS? 2 cos square 1 by 2 into sin square 1. Clearly, this cannot match with 2, not equal to 2, much less than 2. So, x equal to 1, which was the only possibility that lies between 0 and pi by 2, and which will make this equation, which will make the right hand member 2, is not satisfying is not making the left hand member to be 2. So that means that no solution. Therefore, no solution. No solution, and the right option is option 2 is the right answer. Option 2 is the right answer. Question number 17. The most general values of theta for which sin theta minus cos theta is equal to minimum of the expressions 1 comma a square minus 6a plus 11, where a is any real number, are given by first option n pi plus minus 1 power n into pi by 4 minus pi by 4. Second option n pi plus minus 1 power n into pi by 4 plus pi by 4. Third option 2n pi plus pi by 4. Fourth option n pi plus pi by 2. Now we are to equate sin theta minus cos theta to the minimum of two values, 1 comma, what is the second expression, a square minus 6a plus 11, where a is any real number. Let's observe one thing here. This is a variable part and this is a constant thing. Of these two, as a is varying, right, which is going to be the minimum, that has to be equated to our sin theta minus cos theta. So what do I look at the range of a square minus 6a plus 11. What is a square minus 6a plus 11? It is equal to a minus 3 the whole square plus 2. So that is always greater than or equal to 2, because a minus 3 whole square is non-negative. So that plus 2 is always greater than or equal to 2. So here this is a quantity which is always greater than dominating, and that will be dominating this 1. So of these two, which is the minimum? Clearly 1 is the minimum. So sin theta minus cos theta has to be equated to 1. Now so the equation that has been, it's just it is turning out to be sin theta minus cos theta equal to 1. How do we solve it? We have to, I'll multiply by 1 by root 2 both sides. 1 by root 2 into sin theta minus cos theta by root 2 is equal to 1 by root 2. That becomes, this is cos pi by 4, we'll write it as, this is 1 by root 2 here, we'll write it as sin pi by 4. So it comes into the form of sin theta minus pi by 4, theta minus pi by 4 is equal to sin pi by 4. So let's write the general value now. Theta minus pi by 4 is equal to n pi plus minus 1 power n into pi by 4. That's the general solution. So transpose it that side. Theta is equal to n pi plus minus 1 power n into pi by 4. This minus pi by 4 taken the other side, plus pi by 4. So n any integer there. Clearly this is appearing in the option 2. Option 2 is the right answer. Okay, let bracket of x be the greatest integer less than or equal to x, and let f of x be sin x plus cos x. The most general solutions of f of x equal to bracket of f of pi by 10 are n pi n any integer. Second option 2n pi plus pi by 3 n any integer. Third option 2n pi minus pi by 3 n any integer. Fourth option 2n pi or 2n pi plus pi by 2. Let's look at this. Here f of x is given to be sin x plus cos x. What is f of pi by 10? That is sin pi by 10 plus cos pi by 10. That is actually a value which is greater than 1 and less than root 2. Okay, this can be verified. So this will be a value between 1 and root 2. So f of pi by 10, the bracket value will be 1, because it is a number between 1 and root 2, which is root 2 is again less than 2. So 1 and 2, if you give a number, bracket value has to be 1. So now we are trying to equate this sin x plus cos x to then 1. Sin x plus cos x is to be equated to 1. Okay, that makes it again sin of x plus pi by 4 is equal to sin pi by 4, and that gives me x plus pi by 4 is equal to n pi plus minus 1 power n into pi by 4. That will give us the value of x to be either 2n pi, because if I take n to be even, we'll get 2n pi plus pi by 4, and this pi by 4 will cancel, so x is 2n pi, or if n is odd, we'll get 2n pi, 2n plus 1 into pi minus pi by 4, transpose it to the other side, we get 2n pi. So we can even write it as 2n pi plus pi by 2. So x can be 2n pi or 2n pi plus pi by 2. Option 4 is the right answer.